In lesson 2.6, we're going to answer the question, how do you write a geometric proof? To start out, we have two theorems. The first and the second are both things we've seen before, but now we just apply them to segments and angles. So segments follow that reflexive, symmetric, and transitive property that we've talked about back in a couple lessons ago. So if you have like a segment AB, what the reflexive property tells you is that segment AB is congruent to itself. So it's congruent to segment AB. So remember, that's the property that tells you nothing changes. The symmetric property is that flip-flop property. So if you have segment AB congruent to segment CD, then you can flip-flop the order and say segment CD is congruent to segment AB. And lastly, the transitive property where you cut out the middleman. So if segment AB is congruent to segment CD and segment CD is congruent to a third segment EF, then you can cut out the middleman and just say that segment AB is congruent to segment EF. All right. Well, hey, guess what? That stuff also works for angles. So if you have some angle 1, well, then the measure, or we won't say the measure, but we'll just say angle 1 is congruent to itself. Angle 1 is congruent to angle 1. And if you have an angle 1 congruent to angle 2, then you can flip-flop it in the symmetric property and say angle 2 is congruent to angle 1. And lastly, the transitive property tells you if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then you can cut out the middleman and just say angle 1 is congruent to the last angle, angle 3. Okay, we're just going to quick run through those three properties and see if you can identify which one the following examples are. So I would like you to pause the video for a moment and see if you can do 1, 2, and 3 yourself. Okay, so go ahead and pause. All right, so hopefully you gave that a shot and you found that the first property was the symmetric property. The second was the transitive property. And the third was the reflexive property. Okay, if not, make sure you change that in your notes and ask me if you're not sure why. All right, so we're going to look at writing our very first proof, and we're going to do this one step by step together. Our first proof, there is a typo here, so what I'd like you to do right off the bat is we're actually going to prove that segment AC is congruent to segment BD. So make sure you put those segment symbols and then the little squiggle that shows that they're congruent. All right, so let's get started. The first thing that we can do is start with what we know. Well, if you look at the picture to the right here, you've got this little tick mark on AB and on CD. So what that tells you is that segment AB is congruent to segment CD. All right, and that's just given in the picture. So our reason for that, it's just given. We don't really need a reason other than that. Now is when you might want to pause the video and get your proof writing toolbox handy because we're going to use that throughout the rest of this lesson. So if you need to do that, pause and go ahead and do that now. So our first step is we want to get to this. We want to prove that segment AC is congruent to segment BD. And what we're going to start with here, this is called a two-column proof, where you put your statements in the first column and then your reasons for those statements in the second column. So we somehow have to get from 1 all the way down to 5, and there's a logical way we can explain this. That's what a proof does. It explains things step by step with logic. Okay, so what we're going to do is, if you notice in your proof writing toolbox, if you look at congruent segments, What that tells you is that if you know two segments are congruent, then you know they have the same lengths. That, frankly, is just the definition of congruent segments. If you know they're congruent, you know their lengths are equal. Okay, so what I'm going to do now is I notice that the length of A to B is equal the length from C to D. But I want to get to this. I want to get to that AC, this longer segment, is congruent to BD. And I notice that they both share this segment BC in the middle. So what we can do here is start with our AB and start with our CD, and to both sides of that, we're going to add segment BC because that is shared between those two. Well, why can we do that? What did we do? We added BC to both sides. Just like we would in any equation, that's the addition property of equality. So if you add BC to the left and you add BC to the right, that's what that property looks like. Now the last thing I notice is that if I erase all this and just kind of clearly look at one thing, I'm saying that AB plus BC on the left. Well, look, AB plus BC is AC. So let's replace the left side of that equation with AC. Let's do the same thing on the other side. I notice that I am adding CD plus BC. Well, guess what? That is BD. So let's replace this side of the equation with BD. Now, why can we do that? What tells us that two segments added together is a larger segment? If you look at your proofreading toolbox, that's actually the segment addition postulate. So you can just put segment addition. Now our last step is backwards from where we started. We're saying AC is equal to BD. Then we're saying segment AC is congruent to segment BD. If you look above, that's again using the definition of congruent segments. Okay, so we went from what we knew to what we wanted to show using a process of steps and logic that clearly could show this to anyone that was reading it. And that's what we want to do in a proof. So we're done with that one. Now what I'd like you to do is I want you to complete this next proof on the back of your notes by yourself. Before you do that, you need to fix something for me. Here where it says subtraction property of equality, cross that out. And instead what you're going to write is the measure of angle 1 is equal to 180 minus the measure of angle 2. Okay, so that's just a typo. Cross out that second thing in the word bank and write in what I have written below instead. Okay, so you have 4 choices over in your word bank. Angle 1 and angle 2 are supplementary. Definition of supplementary angles. Angle 1 and angle 2 are a linear pair, and that the measure of angle 1 equals 180 minus the measure of angle 2. So you need to figure out where those go in the proof. A couple hints for you. What you're trying to prove will always be your last statement. And the other piece of useful information is that what you're given almost always goes first. So those are a couple of hints for you, and then you've got a couple other things to try and figure out using your word bank and using that proofreading toolbox. When you're done with this, you can try to do the rest of the examples on the back of your proofreading toolbox. And then when we're all done with the video, we're going to do this last example together as a class. Okay, so I'd like you to right now see if you can finish this proof. If you feel like you want to give this a shot and try the last example in the notes, do your best. We'll go through that before you leave today. All right, good luck.